Hey everybody, in this video we're looking at an AWS architecture for voice transcription and analysis. Something that I, for instance, use all the time through software because like when I do a podcast, we're creating Substack articles out of this and so on. Or the YouTube videos, we're extracting the data from these through transcription, through voice to text. So I'm excited about this. I'm going to give you my feedback as well as an engineer, what I think about the platform. So I hope you learned something. And if you have questions, put them in the comments. And if you want to look at the thing yourself, then I have the original video in the description. So let's get into it. All right.
Hi, I'm Nuan from AWS.
And I'm Ben from Assembly AI. And this is my architecture.
All right. Oh, okay. We are already seeing a lot of ECS here. Container service, a message queue, CloudWatch metrics, S3, another message queue, ECS. Okay. Nice.
Ben, tell us a little bit about Assembly AI and type of challenges that you are solving with this architecture.
Yeah, at Assembly AI, we're laser focused on developing ML models to understand human speech with superhuman ability. In a nutshell, we have a complete AI system for customers to get the most out of their audio data. The three challenges that we're trying to solve with this architecture are scalability, so handling millions of requests per day, ease of deployment and iteration, so developing new models quickly and updating existing models, and security and compliance, making sure we work with customers to meet their various compliance needs around the globe.
What kind of users interact with this system, and can you explain the user workflow here?
Yeah, all sorts of users interact with us via an API, whether it's podcast companies looking to understand the content on their platforms or telephony companies looking to evaluate and understand call center performance. It all starts with audio, though. So customers, Assembly AI users, upload.
They upload the data through an API, right? That's how I see this. So most likely that's already missing from here, but let's see.
Their binary audio data to our API or submit a reference to that data from something like their own S3 bucket.
And then the flow continues from that ECS component that's the API manager, and then moves to the Amazon ECS here. Can you explain the?
Okay. They're not using API gateway or something. This is the API that is hosted through ECS as a container, as a containerized application or API. Interesting. Okay.
The flow bit too?
Yeah. After we've validated the request and recorded what type of features they want,
Right.
We send that over to our orchestrator. This thing is the brain of the operation that really decides what models to call and in what order. After we've completed the request for the customer, we send a notification over SNS, which is subscribed to by a variety of services, one of which is this webhook Lambda. This notifies customers in an asynchronous fashion that their transcription is completed.
I know.
Okay. So that's how basically it is. Whenever here, whenever this says, okay, I'm finished, right? I have your data, then this is subscribed to the SNS topic. So once the notification comes here, the Lambda starts and the Lambda reads the notification and then basically sends it to the user and the user knows. And then the notification or the message is then deleted from here. And yeah, that's it. Okay, so that's the brain. I hope they talk a bit more about this because this needs to call services, right? This needs to call services with the data, and also this data needs to go to some storage here. Let's say just S3 or some storage. So that is missing from here. Let's see.
No, there's this part of the architecture that we didn't talk about, and I assume the orchestrator here that you talked about delegates that task into the inferencing here. Talk us a little bit about what's happening here.
Yeah, well, the orchestrator, like I said, might be the brains of the operation. all the work gets done over here in this inference pipeline. We have dozens of models deployed. We're iterating on them constantly, so deploying new versions, new models, really laser focused on finding ways to deliver that value back to customers. So this orchestrator sends messages into SQS, which drives our actual models running on ECS to scale up and down and to perform inference on that data.
Okay. How do you use S3 in this architecture?
Yeah, so audio data, as you can imagine, is pretty big. So we actually pass it by reference from S3 into the ECS container. After a customer has submitted their data to our API, we download it, transcode it, and then it actually gets stored over here in S3.
Okay. So that's the process here. Downloaded and transcoded. So why is the transcoding is here before that? Okay. And then it lands here. Then they have another ECS that takes that message or takes the data, the transcript.
S3, I see. So you explained like you're using SQS and you're building like a queue and the jobs are getting submitted. What kind of speed are we talking about?
Yeah, so we really tried to keep the queue empty. This is an asynchronous system. So we've created this custom scaling loop here. It does a couple of things. It watches the depth of the queue, as well as predicting when a model is going to get called and being able to scale it up in time. So a great example of that would be a customer requesting speaker labeling. So who's talking and when. We know that comes after converting audio into text. So we can pre-scale that service such that the capacity is there right when we need it.
Tell us a little bit about the ML models you use in this architecture.
Yeah, so most requests start with our flagship speech-to-text model. It's called Conformer 2. This takes that audio binary data and converts it into text. From there, we can send it to a variety of different models based on the customer's use case. So speaker labeling, like I mentioned, sentiment analysis, what's the mood of the conversation, and even into things like LLMs, where customers can ask questions about their audio data.
Okay. Now I misinterpreted the goal of this showcase here, right? So where's this here? How can we see this?
From S3 into...
So basically, what they're doing here is their flagship model, as they call it, or transcriber. That is, here's the text data in it, right? Here's the text data. And through there, here are the models. Here's the sentiment analysis, the speaker labeling, and so on. And there, then, I'm using this as I understand this, right? So, okay, now I get it. Again, there's a lot more happening at this step here. This is where a lot of stuff's happening. Actually, the actual transcription.
Can ask questions about their audio data.
You briefly touched upon the scalability aspect. Tell us a little bit about when those requests comes in. How do you scale this pipeline over here?
Yeah, so requests are coming in all the time, millions per day, and we're recording that in CloudWatch. And we know, based on the decision engine inside our orchestrator, which model and in what order they're going to be called. So using signals like queue depth and our custom scaling, we can provision more containers for more models. So popular models are going to be scaling up and down more quickly than less popular ones, as an example. In general, these models are pretty expensive running on GPU. So we really like to have good scaling to control cost.
Tell us a little bit about security.
Okay. So they're scaling on the right side, that container that we saw, these are the models, and they're scaling these up and down so they can get more throughput. Okay, interesting.
How did you handle security in this architecture?
So there's a lot of non-functional requirements, compliance things like that we provide for our customers. We're SOC 2 Type 2 certified and really care about following best practices for storing data. We have strict lifecycle policies over here in Amazon S3, so we keep the data only as long as it's useful for our orchestrator and for our ML pipeline.
Yeah, that's always important, that you only keep the data as long as it's really needed and then remove it. So, okay, cool.
That's awesome, Ben. Thank you so much for explaining this architecture to us. I really enjoyed the conversation.
All right, so I hope you like this. I find this very interesting. The only part that I didn't like about this, we didn't see, or we weren't able to see the actual transcription process. We were able to see the data is coming in through ECS, through a container that hosts an API, and then it gets transcribed. That one container, or that one ECS instance that is actually making the decision how the transcription works, and then it's getting stored in S3. From there, they are actually then doing the whole analysis. But yeah, I find it a very interesting use case. It looks like that it's very scalable. Again, whenever we see ECS, this is a containerized application. This has Docker containers running, and in the background, ECR, container registry, to actually then have the images for these containers. That means it's also very cool if you want to replace a model that you say, okay, now we developed a better speaker analysis or a better speaker identification model. Then you can just replace the image in ECR, in the container registry, and then from that point on, it's getting used, or the new one is being used. Yeah, really cool. Let me know in the comments what you think. I think this is very interesting. You could also send me something that you want to have reviewed. Yeah, I hope you had fun. I hope you learned something. See you in the next video.